Hey students, welcome back. This is going to be your 6-3 video, but this is the bell ringer posted right here that we are going to do before we take notes. So hit pause, go ahead and answer that, and meet me down at the 6-3 notes, which is grams to grams. 6-3, gram to gram, this is page 10. So, jumping right in, gram to gram. Last week, or the last time we were together, we went over how to do multiple ratios, which was just 2 steps, write a balanced equation, and then do the multiple ratio. Well, today we're taking that a step further. We are moving on, and we're going to actually do all 4 steps of stoichiometry. So let's quickly review them here. So step 1, remember, is write a balanced equation. All right, and this is what we've been practicing for a while. Step 2 is find moles. And when we find moles, in this case, we're going to be starting with grams. So from grams, we're going to divide by the molar mass. All right, divide by the molar mass. We actually learned that in the fall, so that should not be new to you. Our next step, step 3, is that multiple ratio that we spent a lot of time practicing last week or last time we were together. Multiple ratio, this is where we put where we're going over where we've been. All right. Then our fourth and final step, this is where we go to where we're going. So in this case, we're looking for grams in most cases. So we're going to find grams, and we do that by multiplying. I almost forgot how to spell multiplying for a second. Multiplying by molar mass. All right. So at the beginning of each problem, we'll probably start by finding molar masses of our substances so we don't have to do that later. It kind of should help us out. All right, so let's take a little peek here at our first question. And we've actually got 3 parts to this question, and we're going to kind of work through that there. So maybe up here when we say write a balanced equation, we maybe say find molar masses too, right? So we can kind of go with the flow once we start our t-chart and start our stoichiometry. So you definitely need a calculator and a periodic table. If you don't have that with you right now, please, 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 quickly grab your periodic table and calculator. All right, so let's jump in. So, a first step, write a balanced chemical equation. We have copper 2 chloride. So, copper 2, that means Cu and it's +2. Chloride is Cl and it's -1. So, our correct formula should be CuCl2. All right, and it says and aluminum. So, we're going to add aluminum here. So, we put Al. They react. And let's go ahead and color code this because I think it will be helpful for us. So, we'll hit a little plus sign right here, a little arrow right there. Let's make aluminum purple. So we've got aluminum. React to form copper. All right, let's go green there. Copper and aluminum chloride. So let's make that blue. Hopefully they're different enough. All right, so now if we look, we have 2 chlorines, 3 chlorines, so we're going to need to balance that. So we'll definitely need a 2 here to give me 6 chlorines. So how do I get 6 chlorines on the other side? I put a 3 there. Now I have 3 Cu, so I need 3 Cu, so I'll put a 3 out front. Going back to our aluminums, we have 2. Is that the right color? Yeah, it looks good. All right, awesome. So that is our balanced chemical equation. So that was like step 1. Now we're ready to move on, but we have these little boxes, and these boxes are meant for our molar masses. So that way we don't have to work too hard at it. So I'm just going to draw little arrows for each one that goes where they're at. So CuCl2, what we do there, Cu, right? We have Cu, we're going to take 1 times 63.546, which is obviously 63.546, right? Then we have Cl, we have 2 of those times 35.4527. All right, that's like 70.9 something, blah, blah, blah. All right, and when we add that all up to get our amount, remember we're keeping 2 decimals, we're going to say 134.45, and that's grams per mole. All right, so rolling on, aluminum should be very simple. We find aluminum up on the periodic table. Oh, look at that, 26.98. Again, we're rounding to the nearest hundredth, so grams per mole. Let's go ahead and knock out Cu while we're here too. How about 63.55? Again, rounding to the nearest hundredth, so 63.546 rounds to 63.55. All right, now if we do aluminum chloride, this one's going to require a little more work. So we have Al, 1 times that 26.98, 1538, all right, which is 26.98, 1538. All right, we have Cl, we have 3 times 35.4527. All right, calculate that, add that up, and we're going to get for aluminum chloride 133.34, and that's grams per mole. All right. So there we have our molar masses. So now we're kind of ready to start our problem. So step one, let's go ahead and read this problem, I guess. We've already done step one, write a balanced equation, but let's go ahead and read through. It says how many grams of aluminum? So we're looking for aluminum and grams this time, and we're starting with 10 grams of copper 2 chloride. All right, so we're going from basically, we know this, we know we have 10 grams, and we're going to our question mark there of aluminum. So we're going to start with our T-chart, 10 grams of CuCl2. All right, we're going to make ourselves a little T-chart here, nice long one. All right, now, step one, write a balanced equation. Step two, divide by the molar mass. So we go up top and we find CuCl2's molar mass, and that is 134.45, and that's grams of CuCl2. It's all about unit canceling, right? 1 mole of CuCl2. Awesome. Now we're at moles. We're ready for our mole-to-mole ratio, and this is what we practiced a lot last week. So we're ready to we're going to put 3 moles of CuCl2 on bottom because that's from our balanced equation. That's why I used red, all right? And on top, we're going to go 2 moles of aluminum because that's where we're going, all right? And our last step is to multiply by the molar mass of aluminum. So I'm going to say 1 mole of Al has a molar mass of 26.98 grams. All right, and we're ready to do the math here. We'll multiply across the top, divide by what's on bottom. So we're going to take 10 times 2 times 26.98. Then we're going to hit divide by 134.45 and divide by 3. And that will be our answer. Remember, we're going to try to keep 2 decimals in our answer all the time. So 10 times 2 times 26.98 divided by 134.45 and divided by 3. That should be our answer. We should get 1.34 grams of Al. And there we have it. Awesome. So let's see if we can't do that next one. Now that we've done, like, kind of had the work out of the way, let's go ahead and look at that next one. I'm going to do this next one in this dark green, forest green color here, so we can kind of see the difference. All right. So it says, using the same reaction, which we have above, how many grams of copper 2 chloride, CuCl2, would be required to react to form 25 grams of copper? So this time we have 25 grams of copper, that's a G, and we're looking for copper chloride, so question mark. So we can go from a product to reactant on this without very much trouble. So let's start our T-chart. We've got 25, oops, excuse me, take that away. Oh no, we wanted that. 25.0 grams of Cu. Make our nice little T-chart, nice and long for us. There we go. All right, so second step, divide by molar mass. We have copper this time, so we're going to divide by 63.55, right? That's the molar mass of copper, 1 mole of Cu on top. Grams of Cu cancel. Now we're ready for our mole-to-mole ratio. So on bottom, we're going to put like this little neon green, 3 moles of Cu. On top, we're going to put where we're going. In this case, it's copper 2 chloride, so we'll put 3 moles of CuCl2 on top. All right, and if you can see, hopefully you're looking through that and you're seeing, oh, that's going to cancel. You're absolutely right. Not only do moles of Cu cancel, but those 3's cancel, so we don't even have to include that in our equation or in our problem when we type it in our calculator if we don't want to. All right, and our last step is we're going to multiply by the molar mass of CuCl2, which we found above, 134.45 0.45 CuCl2. Moles of CuCl2 cancel, so we're ready to do our math. Let's blow this up just a little bit. We're going to take 25, maybe not that much. Woo! All right, we're going to take 25 times 134.45 divided by 63.55. And that will be our answer because those threes canceled out. So 25 times 134.45 divided by 63.55. And our answer is going to be 52.89. 52.89 grams of CuCl2. And there we have it. Awesome. See you on the next video.